Hello everyone, Atheatos here, with another video on this little 386 motherboard, the M326, and the topic today is overclocking and underclocking using an external clock source. This motherboard integrates an AM386DX at 40 MHz. So yeah, this is our target chip for today. And you can imagine I had a lot of fun overclocking this system the last few weeks. So here I am with this video to present to you how I did it and also my results. Those of you that have not seen my original video review of this motherboard, I suggest you to first do so by clicking the link up here. Now from the last time, first of all I did a few hardware modifications to this motherboard. Yeah, of course I added here a passive cooler on the CPU. Nothing too special, but yeah, it can make a difference. Then the motherboard originally came with 20 nanosecond cast chips. I replaced them with some 15 nanosecond ones. I don't think this makes any difference as the original ones are actually rated for operation up to 50 MHz. But it just happened I had some new old stock of this one, so yeah, I gave it a try. The tag chip is already 15 nanosecond. Then I replaced some of the caps here near the power connector. You see, in general, okay, the capacitors in this motherboard were not broken, but these are actually very low quality ones and only 10 microfarads in capacity. When I tested them, they also had a 5 ohm ESR that is actually very high. So the ones I used here are 100 microfarad with less than 1 ohm of ESR. I don't think this change had a big effect, but in theory should be for sure better. Also here in this side near to the CPU I added one more, and again this in theory should help a bit the stability of the system. Now of course the main topic of today's video is the modification to this part of the motherboard here, that is the clock generator. Yeah, the main chip here, this PLL52C05, can actually only provide 4 frequency options, and the motherboard only implements 2 options actually, the 33.3 and 40 MHz. So in order to get anything else, the only option is to modify the circuit here and provide an external clock. These PLLs generate 2 clock sources. The one is the reference clock that is typically around 14 MHz, and the other is the CPU clock. The CPU clock for 386 systems is always double the real clock. So this chip actually generates 80 MHz when you select the 40 MHz option here. Now the CPU clock output here goes to this resistor, and then from this pin here goes to the main chipset. Then the main chipset generates again the CPU clock that goes here to this clock buffer, and finally the clock buffer drives the CPU. So that means that it's actually quite easy to mod this motherboard. And the first step is here to remove this resistor from the one side only. So now this unconnected hole here is actually the master clock input of the system. And this side of the resistor is the output of the onboard clock generator. So then I got a pin header and I bent one of the pins. And finally soldered it here in this hole, with the resistor connecting to the other pin of this pin header. And actually this is all that you need to do. So now if you connect here a jumper, the board will work exactly as before, but you also have the option to provide an external clock in this pin. The other nice thing also is that here this jumper that normally selects between 40 and 33.3 MHz, if you remove this jumper, you also have the power supply and the ground here that you can use to power your external clock generator. Now for the external clock source, I recommend you to use an oscillator like these ones. The only thing you need to pay attention to is to select one that supports a 5 volt power supply. And yeah, as you can see, these are available in many different values. Of course, for overclocking we are interested in values above 80, and there are a few options. So yeah, I have a few of them here, and of course this is the simplest solution, but simple is not for me. What I did was to build this little thing here. This is based on an outdated clock buffer clock multiplier chip, and I did a lot of research to find the ideal one. So you can put any crystal here, then it's multiplied based on these jumpers, and you get the final clock output here. Now if you combine this with around 20 values of different crystals, you can basically get any generated frequency up to maybe 200 MHz with a step of only something like half a megahertz. If you are interested more into this, just give me a like on this video. If the video gets, let's say 100 likes, I will come back to you with another video where I will describe in detail this one and all the values of the crystals that I used. So now back to our motherboard, and here I have configured it to work as before, so this jumper is on. So the first step to plug the external clock generator is to remove these two jumpers. And now we are here, and I just need to connect the ground, the power supply and the clock output to 3 of these pin headers. And here we have the final result. It is important to keep these wires as short as possible, as at this rate there is significant deterioration of the clock signal. And of course this little device, I just made it to test it, and in the future I will build a proper PCB for this one. So that's all with hardware modifications, and I think this is a good point to discuss a bit about my overclocking results. So let me first of all say that I used the same configuration I used in my original motherboard review. So that means 0 wait states for the memory and very aggressive timings for the ISA bus. So I started from 40 MHz and then raised it step by step. And the first wall I hit was around 43 MHz, and the limitation was with the memory, as the modules I had on board were these 60 nanosecond ones. Then I switched to my own 50 nanosecond fast page mode memory modules, and I was able to push it further until 46 to 47 MHz, where again in the end I had to increase the wait states from 0 to 1. But of course the important point here is that for the first time I see a benefit from using my own 50 nanosecond memory modules. So in the end, as I said, after 47 MHz I had either way to set the wait state to 1. And with this setting the memory was not a limit anymore. However, I have plans to create also some 40-45 nanosecond memory modules in the future, so I'm not giving up on 0 wait states. And here I already have the chips and the new PCBs, so I will come back to you with another video, and of course you know what you should do if you don't want to lose this. So back to our motherboard. So I continued to push it further after 47 MHz, and at first it worked perfectly fine until I hit 50 MHz. But after a few days that I retested this, I had a lot of stability issues there. I'm not really sure about what changed, but probably the reason was that the weather actually got a lot warmer. So then I just placed on top a desktop fan, and in the end the system was again stable at 50 MHz. I then tried to push it a little bit further, but it's clear that the limit is around there at 50 MHz. So here we are with the system running at 50 MHz, and as I said, the only thing I had to do was to set the DRAM wait states to 1. The interesting thing was that I was still able to run the ISA bus with a divider of 3. That means that the system was stable with an unbelievable bus speed of 16.6 MHz, and that's of course great for our system performance. Then there is something more to note here with the cache options. As someone noted with a comment, this option actually has no effect in this motherboard, and I actually verified this. So in the end, okay, I kept it here at 2111, but yeah, doesn't make any difference. So first of all, let's have a look with speeches. And on the left I have the result at the default 40 MHz. And on the right is the overclocked 50 MHz one. The score here is 11.68. That is basically exactly an increase of 25% from the 9.35. So yeah, this is in line with our 25% overclock. Then also here there is a significant increase in the speed of the L1 cache and memory speed. The L1 cache had again a flat increase of 25%, but the memory throughput only increased by something like 13%. This is probably due to the fact that we are now running with a wait state of 1. Finally, the craziest thing here is the hard disk throughput with a read speed of 3.5 megabytes per second. Actually, this overclocked 386 machine with a NISA hard disk controller can beat most 486 machines with a VLB disk controller. Also again, the performance increase from the standard 40 MHz configuration is about 22%. Now let's also have a look in the checker tool, and I like to run this real-time clock checker. This is good to verify that the reference clock is the same as before, and the test passes. Now the benchmarks with first of all the main system benchmark, and you can see here the 50 MHz 386 and the final score, and here again the video score. Finally, I will run here the hard disk tests, and we can see again we get more than 3.1 megabytes per second. And the final information tool is landmark, and we can see again 50 MHz 386 DX. Now back with the classic benchmarks here, and 3D bench with a score of 21. Then PC player benchmark with a score of 4.5. And finally, of course, Doom. This looks actually quite good for a 386 machine. Of course, okay, it's not playable. The score here is actually close to 9 frames per second. And if we run for slow PCs with option A, we can see here it runs really fast actually. But of course again, I don't think many people will say that this option is playable. However, this result corresponds to around 34 frames per second. Final benchmark here the VGA speed with a score of 68.3 frames per second, and also bit speed here. So here we have the table with all the results for different configurations, and what we have added today is this one, overclocked at 50 MHz. Below I also have a case for 52 MHz, but yeah, this configuration was extremely unstable, and actually I only managed to get these benchmarks to run once, so yeah, I don't really get into consideration this case. Now the 50 MHz one overperformed the 40 MHz optimized configuration by 23.3%. This is a bit lower than the theoretical 25%, but yeah, it's probably caused by the increased wait states in memory. So now in total, if we compare the basic unoptimized configuration with the fully optimized and overclocked configuration, we have a nearly 41% increase in 3D bench, a similar performance increase in PC player benchmark, then nearly 66% increase in Doom, and 300% and 150% increase in VGA and vid speed respectively. So in total what we have managed here is to boost our system performance by about 96%, from 3.46 to 6.86. So that's all for the overclock, at least for now. I will sure try to push this a bit further, and I have some ideas regarding this, so I might come back to this topic in a future video. Now regarding underclocking, of course I use the same configuration here with the external clock generator, and this time I tried lower and lower settings. Then I hit the wall around 15 MHz. The system was actually freezing at memory count. And then of course I tried the turbo function here. If you place a jumper in this position, the system actually operates at half this frequency. So while in normal operation the clock source is divided by 2, with the turbo jumper here the clock is divided by 4. But the important thing is that when I placed this jumper here, I was able to bypass the problem with the freezing during memory count and go to even lower frequencies. So in the end I was able to run this 386 machine at the very low speed of 2 MHz, and I was done so by providing here a 8 MHz clock and having the turbo jumper on. In theory it might be possible to go even lower, but okay, I don't have the crystal right now, and of course this is a bit pointless, and you will see soon enough why this is so. So here I have the system running at 2 MHz. And first of all, let me tell you that yeah, it's very funny because when you turn on the switch, the system takes something like 10 to 15 seconds just to show anything on the screen. And here you see the boot sequence and how remarkably fast it counts the memory. Yeah, you get the idea. Then of course in the BIOS I have disabled the motherboard cache. And of course in the advanced settings I have set all to the slowest possible configuration. For the ISA bus I have selected this CPU clock divided by 2. That means that my ISA bus should probably run around 1 or 2 MHz. So here we have again a glorious memory speed running. And of course at this point I had replaced my 16 MB memory kit with a 1 MB memory kit because I wanted my mental sanity intact. Okay, I respect my viewers' time and I will speed up a bit this. So here we have booted and I run the check it tool. Well, this is the first time I see this drawn the correct way. Let's see the main system benchmark. And it's reported as 386 2 MHz. And yeah, this score is totally ridiculous. It is 1/3 the performance of the original IBM PC. And the video system benchmark that actually gives a very similar result. Then, okay, here the hard disk benchmark with 80 kilobytes per second. So basically we managed to drop from 3.1 megabytes to 80 kilobytes. The ISA bus is probably severely bottlenecked here. Then I ran a bit of VGA speed and here it's 0.7. This is something like 90 times slower than before. And vid speed with a score of 300, something that is like 25 times slower. Now look at this. This is how fast the menu loads on Field Computer Lab DOS Benchmark suite. And here of course I cannot run most of these things. Yeah, top bench gives a score of 1. And here is again how fast this menu loads. So yeah, this is a landmark system speed test running on a 386 machine at 2 MHz. And yeah, this is the sound of please put me out of my misery. Now you are probably asking what is the point of all this? And actually by underclocking this 386 machine we can play some very old speed sensitive games from the original IBM era. First of all I have this flight game, and yeah, these games are so speed sensitive that even some modern clone systems of the 8088 CPU fail to run them in proper speed. Let's see how this runs. I will skip the intro. Yeah, this actually looks very slow, probably slower than normal. Yeah, it's definitely too slow here at 2 MHz. But yeah, it works. The next one is around 42. Yeah, this is also quite slow. And yeah, there is also a problem with the graphics. This is due to the fact that I'm using a VGA ISA card, and these games probably need some EGA card, but this is not a problem, as in theory we can plug such an ISA card in our 386 board here. I will come back to you when I have a video card like that. Yeah, this is definitely a bit too slow. And final game here is Defender. This is one of the most speed sensitive games. And I don't know, I have never played the original, but the speed here looks probably okay. Maybe still it's a bit slow though. In the end, being too slow it's not a problem, because of course with my configuration I can set the clock anywhere I want. So yeah, these are my current options, and you can see here the step is actually very small. So then I tried again with a clock of 3.33 MHz. And here we have the check it tool and the landmark. Let's check again our gains. And yeah, here you see, yeah, this looks quite okay actually. Yeah. Yeah, this looks very, very good. Next, round 42. This sounds okay. Yeah, and plays quite good. I got a bit lost playing this game. It's quite interesting actually. Finally we have Defender here. Yeah, I don't know. It is a bit faster. It looks quite playable to me. And with this I think it's time to end this video. The conclusion is that first of all, this motherboard with AM386DX can be overclocked to 50 MHz. But yeah, this is a bit on the limit, and probably you also need higher quality memories. And the second conclusion is that by underclocking, it is possible to play even the most speed sensitive original IBM XT games. So that's for today. You know what to do if you liked this video. I will come back to you with more videos like that for sure. So see you again next time.